There are 5 different factors that can increase your rate of reaction, aka speed up the reaction. I'm gonna start talking in the order of the most obvious one to the least obvious one. So here we go. Number 1, stirring. When you dip in chocolate powder into your milk, you should probably stir it thoroughly if you don't want to end up swallowing a chunk of chocolate powder that wasn't fully dissolved. Let's be real, we've all been there before. It ain't too good of a feeling. So clearly, stirring helps the dissolving reaction to happen at a faster rate. Chemistry speaking, we're adding emotions to the molecules, so the molecules move around faster, and therefore the reaction proceeds at a faster rate. Number 2, increase the temperature. Say I want a green tea with some honey. If I want it right now, I should probably make a hot one instead of a cold one because it's gonna take me some time and efforts to dissolve the sticky chunk of honey in an ice-cold green tea. It's a common sense that stuff like honey will dissolve better in a higher temperature than in a lower temperature. To speak this in chemistry term, temperature is a measurement of kinetic energy. Kinetic energy is energy due to motions. So, higher temperature should mean more motions, meaning they move around faster, so they dissolve faster. Number 3, increase the concentration of reactants. So this is where it starts to get a little less obvious, but bear with me. How does increase in concentration of reactants lead to a faster reaction? In chemistry term, more reactants should mean more molecules floating around, and that should ultimately mean more chances of collisions between those molecules. Therefore, more molecules will make more collisions, aka reactions, so the reaction will happen at a faster rate. You didn't like that explanation? Well, here's your alternative one. Let's say my friend Victor and I work at Chipotle. If it's 12 p.m. lunchtime, he and I better work our ass off because there's a whole line of people waiting to get their burritos. But if it's around 3:30 in the afternoon, I highly doubt we'll be working hard because there's barely anybody coming by around that time. So there you go. More people at Chipotle, we gotta work faster. More reactant molecules floating around, the reaction has to go faster. Number 4, increase the surface area. Let's go back to our chocolate milk example. I was talking about dipping in chocolate powder, but imagine I throw in a whole chunk of chocolate and wait the next 4 hours until I get my chocolate milk. It'll be the dumbest idea. Let's think about why though. Imagine I grab 2 big flat bowls and I'll put a chunk of chocolate in one of them and put powdered chocolate in the other one. And then I'm gonna pour milk into both of them. If you can visualize, every little particle of chocolate powder gets to react with milk and dissolve, whereas the chunk of chocolate only gets to react with the milk on the outer surfaces that are exposed to milk. Therefore, since powdered chocolate particles have much more surfaces at which the reaction can take place, the reaction rate should be faster. Number 5, add a catalyst. Here's a confession. As much as I love my dairy products like milk, cheese, and ice cream, man, it just sucks that I'm lactose intolerant. Now, does that mean I'm gonna die the next day if I chug in a gallon of milk today? No, I just have to take a day off and spend the whole day on a toilet, but it's not like I'm gonna die. This is the idea of a catalyst. People like me who are lactose intolerant don't have this thing called lactase. Lactase is a piece of protein that's crucial for digesting lactose molecules in milk. Just because I don't have lactase, it doesn't mean that I can't intake lactose at all. It just means that it's going to take me multiple diarrhea for the day, but it'll eventually exit out of my system. People who have lactase, they don't need to go through this because they have this catalyst called lactase. So, we can see that this thing called catalyst helps to speed up the rate of reaction because people with lactase clearly digest dairy products way faster than I do, without pain too. But in terms of chemistry, the question we should ask ourselves is, how? If this diagram doesn't seem familiar to you, please look at the description below and follow my link to Understanding the Energy Diagram. If you look at this part, this uphill portion is what we call the activation energy. As the name gives it away, it is the amount of energy required for you to activate the reaction, aka get the reaction started. If you look at the uphill right now, it's pretty high. I always like to think of it as me riding a bicycle on that track. Right now, it's going to require a good amount of energy for me to climb up that hill. But what catalyst can do here is that it can lower that activation energy to maybe about this much, and therefore, you don't need that much energy as before to get the reaction going. Going back to my bicycle example, I only have to go up this little hill, thanks to catalyst, to finish my race, so I'm going to finish my race faster. So bottom line, catalyst lowers the activation energy, so the reaction doesn't need that much energy to get going, so the reaction will occur at a faster rate. If you found the video helpful, please like the video, subscribe to my channel, and let me know if you'd like me to cover any other topic in the comment section below.